As you just saw, they're building a bridge downstairs for the junior steel bridge competition on Saturday. On the bridges they're building, they use lots of these. A truss. Lots and lots of trusses. So basically, a truss is this, which is entirely made up of 2 force members, as you can see. This is a miniature version of, or a piece of a truss from an entire bridge. So basically, trusses are awesome because they can help to distribute the weight amongst the entire bridge rather than just like at a singular point. So they don't fail.
In 6.48, the problem is a truss problem, and it asks to determine the force in HD, BG, and BC, and then also to state whether these members are in tension or compression. So this is the free body diagram for it. The first step in solving the truss problem is to determine the support reactions at E and at A. A is a pin, and then E is a roller. So A has components in both the X and Y direction, and E is only in Y. And so we do the sum of the forces in the Y direction. So we sum up all the forces, and because it's a statics problem, it equals to 0, and we get a function. And then we do the sum of the forces in the X direction, and we find that AX is equal to 0 kilonewtons. And then finally we do the sum of the moments at point A, and then we find that EA is equal to 8 kilonewtons. So then putting that back into the first function, we find that AY is 9 kilonewtons.
Okay, so we cut the truss along section KK, and we took the left side because it has the least amount of forces, and that leaves us with 3 unknown forces, FHG, FBG, and FBC. Before we determine the forces, we use trigonometry to determine the interior angles. So we found that alpha is equal to 26.57 degrees, and beta is equal to 56.31 degrees.
So once we cut at section KK, we take the moments at G, with counterclockwise being positive, to find force FBC. When we take the moments, we do force times distance there, and we have 1 unknown and 1 equation. So we just calculate using algebra and determine that FBC equals 0.8 kilonewtons. Then we go to sum of the forces in the Y direction and sum of the forces in the X direction. However, we have 2 unknowns and 2 equations. So using sum of the forces in the Y direction, we come up with a function with both FHG and FBG. And then using sum of the forces in the X direction, we come up with another function with both of those variables. And then using systems of equations, we solve for those and determine that FBG is 1.83 kilonewtons and FHG is 10.1 kilonewtons.
The final part of the problem asks whether or not the members are in tension or in compression. And once we solve for the values of each member, we find that because the values are all positive, all 3 members are under tension, and this is because their internal forces act towards the center of the members.